Okay, today you're going to be in 8.3, the first of many parts of 8.3. In this lesson, you will recognize, write, and find the nth terms of geometric sequences. In a geometric sequence, there is a common ratio, as opposed to the arithmetic sequence has a common difference. Common ratio is if you take the ratio of two numbers, it's always going to be the same number. Or we can say that we're going to have the same multiple each time. 7 times 2 is 14. 14 times 2 is 28. 28 times 28 times 2 is 56. This is a geometric sequence because there is the same number being multiplied each time. We call that number the common ratio. You find that common ratio by dividing the next term by the previous one. So you're going to divide the 14 by 7 to get 2 because we multiply the 7 by 2 to get 14. Or the 28 divided by 14 to get 2 and 56 divided by 28 to get 2. All of these have to work. All of these in here have to be the same. Okay? Alright, so this is my geometric sequence. Is this a geometric sequence? And if it is, give the common difference. Well, you can find that by dividing negative 18 by 6, and you're going to get negative 3. And when you divide 54 by negative 18, you get 3. When you divide negative 162 by 54, you also get 3. So this is a geometric sequence with a common ratio r of negative 3. Okay, geometric sequence, yes or no? Well, this is times 4. Then nope, it's not, right? 4 over 1 and then 9 over 4 don't equal each other. So it can be a fraction. 9/4 is perfectly fine, but it's not the same as 4 over 1. Or it's not the same as 16 over 9. So this is not geometric. Write the first 5 terms of a geometric sequence whose first term is 3 and whose common ratio is 2. So they gave you the first one. We're going to write 5 of them. The first one is 3. So the next one is 3 times 2 is 6. And then times 2 again would be 12 and so on. So the first one is 3. The next one is 3 times 2 is 6. The next one is 3 times 2 is 6 times 2 again, which is 3 times 2 squared is 12. Take that 12 and multiply by 2 again, we get 24. Multiply by 2 again, we get 48. Now I want you to get used to this notation here. We have a 4, 3, 2, 1, and 2 to the 0 power. If you look at these numbers, the n value, this is always 1 smaller than n. So this is 5, this is 4, this is 4, this is 3, this is 3, this is 2, this is 2, this is 1, this is 1, and this is 0. Okay, so we come up with this formula here for finding any term. The nth term is the first term times my common ratio to the exponent of n minus 1. Okay, because this is always going to be, the exponent is always going to be 1 less than my n, right? This is 3 and my n is 4. So on. You always take the first term and multiply by the common ratio to the exponent of 1 smaller than n. So this is the formula that you have to have. And we're going to get, in this section, you're going to get like 4 formulas, maybe 5, that look very similar. So know that this is for finding any term, the nth term of a geometric sequence. Okay. Write the first 5 terms of the geometric sequence whose first term is 12 and whose common ratio is negative 2. So if we're going to write this out, the first term is 12. The next one is 12 times negative 2, which is negative 24. The next one's negative 24 times negative 2, which is positive 48. And positive 48 times negative 2 is a negative 96. Next one is negative 2 times negative 96 is 192. Or you can always write it this way if you're looking for any particular one that you want. If I asked you to find the 10th one, you would take 12 times negative 2 to the 9th power. Okay. Here's another one. Write the first 5 terms for a geometric sequence whose first term is 2 and the common ratio is 4. So we have 2, 8, 32, 128, and 512. Okay, now we have something a little different. Find the 15th term of the geometric sequence whose first term is 20, whose common ratio is 1.05. Now we're going to use this formula right here where n is 15. We're trying to find the 15th term, and that's equal to the first one, 20, times r, which is the common ratio of 1.05 to the 15 minus 1 power. So we're going to write it like this. The 15th term is equal to 20, the first term, times 1.05 to the 14th power. When you put that in your calculator, you get 39.6. Let's try another one. Find the 9th term if the first term is 4 and the common ratio is a half. So we're going to say the 9th term is equal to 4 times a half to the 9 minus 1 power, or the 8th power, because it's 1 less than n. So doing that on your calculator, you see that that's 1 over 64. Okay, it says find the nth term of the geometric sequence, and then it also asks you to find the 9th term. Okay, in order to find the nth term, I have to find a1, r, and n. So here we go. We have these three numbers, 5, 15, and 45. First, we need to find r. R is going to be 15 divided by 5, which is 3. You should also double check. 45 divided by 15 is also 3. So that is your common ratio. Right? And the first term is 5. So putting that in this formula, we're going to get a sub n, or the nth term, is equal to 5, the first term, times the common ratio to the n minus 1 power. Now to find the 9th term, you would put 9 where the n's are, and the 9th term is equal to 5 times 3 to the 9 minus 1, or 8. You finishing that on your calculator, you get the 9th term is 32,805. Let's do another one. Okay, given these numbers here, find the nth term of the geometric sequence, and then find what is the 10th term. So my r is equal to negative 2 over 6. Or, if we use these two, it's 2/3 over negative 2. And 2/3 over negative 2 is negative 1/3. And this is also negative 1/3. So that we've double checked both of our ratios, the first ratio and the second ratio. And the first term is 6. So writing that in here, I get the nth term is 6 times negative 1/3 to the n minus 1. If I wanted to find the 10th term, I would go, the 10th term is equal to 6 times negative 1/3 to the 10 minus 1, or 9th power. Finishing that on your calculator, you get negative 2 over 6,561. The 4th term of a geometric sequence is 125. And the 10th term is 125 over 64. Find the 14th term of the geometric sequence. Assume that the terms are positive. Okay, they put this last part here because they give you very little information, and with this information, with a small amount of information, you could have multiple answers, or two answers. So we're going to assume that terms are positive, otherwise we will get a negative answer. So there is nothing special about the 4th term. And if this is the 4th term and the 10th term, and we're trying to find the 14th term, we wanted the first term, right? Our formula uses the first term. Well, let's call this the first term. If the fourth term is the first term, what is the 10th term? So if you lay this out like this, 1 through 10, if you call the fourth term 1, that means the 10th term is really the 7th term. Okay, this makes it nice because now I have the first term is 125. Right? Remember, we're just multiplying. It doesn't matter where we start, which one we call the first one. So we'll have this set up here where now we're going to say this, my first term is 125 and my 7th term is 125 over 64. All right, so the 7th term is equal to the first term times r to the 6th power. So this will help me find r, right? Because now this is really my 7th term, this is my first term, and I can find r. So I got 125 over 64, that's my quote-unquote 7th term, really my 10th term, and my quote-unquote first term is really my 4th term, right? Going by this here, the 7th one is really the 10th one, and the first one is really the 4th one. So that's going to be 125. That's my A4, or I'm going to call that my first term, r to the 6th power. I'm going to divide both sides by 125, and I can cancel the 125s. And I get 1 over 64 is equal to r to the 6th power. Well, I'm going to take the 6th root of both sides, so I can cancel the exponent here. And I'm going to get plus or minus, because this is an even root, of 1/2. But it says assume that the terms are positive, so I'm only going to write the positive 1/2. So now I have r. I can write the nth term is equal to 125. The quote-unquote first term, 1/2 to the n minus 1. So I want to find the 14th term. Okay, the 14th term is really going to be my 11th term, because I'm going to subtract 3 from 4 to get my first term and subtract 10 by 3 to get my 7th term, right? All these are reduced by 3. 10 minus 3 is 7, 9 minus 3 is 6, 8 minus 3 is 5, 7 minus 3 is 4. So my 14th term will really be my 11th term, since this one is really the 4th term and I wanted the first term. So the 11th term is going to be this. Using that on your calculator, you get 125 over 1024. Let me do another one so that you can get a good idea. The second term of the geometric sequence is -18, and the 5th term is 2/3. Find the 6th term of the geometric sequence. Okay, we have to find r, which we don't know, and we don't have the first term. Whenever we don't have the first term or r, we're going to have to use this little trick that I used here. I'm going to lay them all out like this, and since I want my second term to my first term, I'm going to subtract 1 from everything. Subtract 1 from 2, the second one, to get my first one. That means my 5th one is really, subtract 1 is really my 4th term, and I will really be trying to find the 5th one using pretending that this is the first one. Alright, so the 4th term is equal to the first one times r to the 3rd power. 4 minus 1 is 3. Okay, putting some numbers in, my first term is -18. My 4th term is 2/3. Divide both sides by -18. And I get 2/3 by -18 is -1 over 27. Is equal to r cubed. Now, since this is an odd root, I don't have to worry about the plus and minus. It's always going to be whatever the sign r is. So I take the third root of negative 27. That gives me negative 1/3. You can either do that on your calculator, or you know that 3 times 3 times 3 is 27. So r is negative 1/3. Putting that all back in, I get 18 times negative 1/3 to the n minus 1. That's the formula. And since I'm trying to find the sixth one, which is going to be 5 in this formula because I changed the first one, I'm going to have the fifth term is equal to negative 18 times negative 1/3 to the 5 minus 1, which is 4. On my calculator, I actually get the sixth term, right? This was the fifth term based on this fake first term. So my sixth term is negative 2/9. Okay, I'm done with the lesson. This is your Google form. Number 1, determine whether or not the sequence is geometric. If it is, find the common ratio for 1, negative 2, 4, and negative 8. These are your choices. Number 2, give the first 3 terms of the geometric sequence. The first one is 5, and the common ratio is 2. And these are your choices. Number 3, sorry about that. These are going to pop up because they're animated. Number 3, write the nth term of the geometric sequence as a function of n. So this is, you're given the first term and given a recursive of any term is 1/2 times the previous one. The following term is equal to 1/2 times the previous one, and your choices are these here. Okay, and then let's see here. Find the nth term of the geometric sequence. Given the first term is 243, and the common ratio is 1/3, and n is 5. Find the nth term, so you're trying to find the fifth term. Okay. Next, find the indicated term of the geometric sequence. The indicated term is the sixth term, and you're given the first 3 numbers, 7, 21, 63, and so on. You're trying to find the sixth one. And the last question here, the second term of the geometric sequence is 4, and the fifth term is 32 over 27. Find the seventh term of the geometric sequence. Assume that the terms are positive. Okay, that's it.